I wanted to go a little bit more in detail on Magic Square for those who are having some questions about that. Notice that I'm importing random here. That's because I'm going to populate my array with random numbers. You could hard code your values in there. If you wanted to Google and find an example of a magic square and then put those numbers in, you could do that. The odds that I'm going to get a magic square using random numbers are pretty thin, so pretty slim. So a better way to do it would be to hard code some values once you find a magic square online that you know is truly a magic square, and then run your program and make sure it agrees with that. But in this one I did a 5 by 5. Now I'm not worried about you doing 5 by 5 if you find a 3 by 3 magic square and you want to change all the 5s that refer to the array to 3s, or you find another array that has if you find another example of a magic square that's got different dimensions and you want to test that, that's fine. The idea behind this is that you get practice creating a two-dimensional array. And remember, we cannot use an array list for this because there are no two-dimensional array lists. Those are only ever one-dimensional. So I've got my array declared here as a 5 by 5 to hold ints. And then of course I set up my random number generator. And what I do is I populate the array here using my random number generator. Notice that I have to use nested for loops where I'm doing rows and columns. So I like to go across and do row 1 and then row 0, column 0, column 1, column 2, column 3, column 4. Then I like to move to row 1, which is the second row, and then populate each column. So if you want to walk the array row by row, going to the first row and then going to each column, you use nested for loops with the rows on the outside and columns on the inside. And so then I just get my random numbers there. Now if you wanted to hard code it, you would have to literally for each row and column do something like that to hard code your values, and you would have to do that 25 times for a 5 by 5 in order to really know off the top of your head how many total items an array has. You can multiply the rows by the columns, obviously, and that's going to tell me I have 25 items. So you can either hard code the values that way, or you can do like I did, use a random number generator. And here I am literally just printing out the magic square so I can actually see the values that are in it in my output window. And again, I like to go to the first row, which is row 0, and then walk each column and print it out. Then I go to the second row, which is row 1, and then I go to column 0, column 1, column 2, and print those out. And so in order to walk the array in row order again, row has to be on the outside of the nested for loop. Then I just have a nice little statement saying, is it a magic square? And so I had started to put a bunch of variables together to figure out or to hold the sum of row 0, the sum of row 1, the sum of row 2, the sum of column 0, column 1, column 2, the sum of the diagonals. But I decided that really that was kind of painful, and I could not quite get that to work how I wanted to without a lot of code. So maybe a better idea is let's create some additional arrays. I want an array to hold all of the sums of the rows. So since there are 5 rows, this is going to be a one-dimensional 5-element array. And so sum row 0 is going to hold the total when I add up all the numbers in row 0. Sum row 1 is going to hold up the total of all the numbers that are in row 1. So I'm going to accumulate all my sums for the rows here, and then I did the same thing for the columns. So sum column 0 is going to have the total when I add up all the numbers that are in column 0. and so on. So now I'm going to actually get all of my sums, and this might be the tricky part, because remember, I have to add up all the rows, I have to add up each individual column, and then the two diagonals. So if I want to add up the rows, again, I'm walking this by row order as I've done in the prior two for loops. So if I want to walk by row, row is the outer for loop. And so what I do is, if I'm on row 0, I'm going to go through each column, column 0, 1, 2, 3, 4 in row 0, and add them up. And so the way I do that is in the inner loop. As the outer loop is on row 0, the inner loop goes through each column in that row. And I'm going to add them up, and I probably need a little variable here that I left out so I can keep track of the total value of each number as I'm adding it up. And so this isn't the tricky part, but what's tricky is that in order to get the sum for each row, I need to drive off of this row number. So when I'm on row 0, this is going to stay 0. I'm going to go column 0, then I'm going to go to column 1 and add that to the number in column 0. Then I'm going to go to column 1, I'm going to add that to the sum of the other two numbers. So putting row here instead of trying to hard code a number will let me add up by row. Then same type of thing for the columns, and I'm going to use my sum variable again. I'm just going to set it back to 0 here. And actually, I also need to reset sum to 0 each time I go to a new row. I need to set the sum back to 0. And the way I do that is once it's done and it's gotten the value here in the inner loop, then before I go back to the next row, in between the braces for the inner for loop and the outer for loop, I'm going to reset the sum to 0 so that now when it goes to row 1, sum is back to 0. It'll run in here and accumulate the values. It'll store the final total in the right place in my other array, and then I'll reset sum 0. Here I'm resetting it before I go into my loop for the columns. And I'm going to do the same type of thing to make sure sum only accumulates column by column. Okay, so I'm going to clear it out. Notice I have flipped these loops. If I want to walk by the column, if my column is my driving idea here, I want to go down the column. So I want to go row 0, row 1, 2, 3, 4 and add them up. Then go to column 1 and add all the rows up. In order to do that, I just put columns on the outside as the outer for loop. Rows are on the inside, and notice here I'm going by column number and summing everything up. And then finally, I'm going to add up my diagonals. I'm not sure what I was doing there. Or actually, I think I've accidentally deleted some code somewhere along the line. Here I was just trying to show you with this for loop I'm commenting out, and I talked about this in my other recording, that you can of course do nested for loops to add up the diagonal, and the one diagonal that starts on the upper left, you can always find that one because the row number equals the column number. So row 0, column 0, plus the value in row 1, column 1, plus the value in row 2, column 2. So if you look at it, draw it out on paper, you'll see that on that one diagonal, the row and column numbers are equal. So you could do this. This is kind of inefficient. Probably a better way to do it, which you'll see online, is if I know that that's where the two numbers, the row and column number, are equal, I can just use one for loop, have it loop from 0 to 4, and then just use the little counter. If it counters 0, I put 0, 0 here. When the counter's 1, I put 1, 1 here, and so on. and that will allow me to hold in this little diag 1 the value of the sum of that diagonal. And then finally, to walk the other diagonal, it starts in the upper right and goes down. I have to use a formula which is length minus the loop counter minus 1 for the column value, and then that will give me the sum of that. So go to the other recording for more detail on how to walk the diagonals. But now that I've got all of the numbers stored, how do I figure out for sure if it's a magic square? Well, I've got a little Boolean value, is magic. I like to default to saying, let's assume it is a magic square, and then the second we find out that it's not, we flip the value to false. Okay, that's easier than saying it's not, I think, than saying it's not a magic square and trying to prove that it is. Because if you try to say it's not a magic square and prove that it is, you have to do a little more code to say, well, I think it's a little trickier because you've got to make sure every single row, column, two diagonals add up. So I think that that's a little more complicated than just saying assume it is, and the first second I find one where the two sums don't equal, I'm done. I know that it's not. So I go and write a little loop here. And I want to compare in my sum row array, I want to take the 0 element, and does it equal the 1 element? Then does 1 equal 2? Does 2 equal 3? Does 3 equal 4? If all of those numbers are equal, then I know that it's a magic square. I leave magic true. Otherwise, I set it to false, and I can actually do a break statement here and stop the loop if I want. Some people will actually do an if statement like this. They'll go and hard code the numbers and do, something like this. So if the value in 0 and 1 are equal, and if the value in 1 equals the value in 2, and then they'll keep doing and compare each one that way. And then they'll say leave it true, otherwise it's false. So you can do that as well. Now notice I put a 3 here and not a 4. I have a 5 element array. Normally I would loop from 0 to 4. The reason I went to 3 here is notice that I'm comparing each one to the one next to it. And if I put a 4 here, eventually my array would go out of bounds because 4 plus 1 would be 5. And there's no element with an index of 5. So if I put a 3, that works. That's a 0. It compares 0 to 1. Then it compares 1 to 2. Then it compares 2 to 3. Then it compares 3 to 4 and tells me whether or not it's a magic square. I do the same thing with the columns, and once I figure out it's not a magic square, I could break the loop. I could also put an if loop here to say if it's still a magic square, do this loop, otherwise ignore it. So there's a couple ways you could do this. And then finally, I check the diagonals. And here, I only check them if I think it's still a magic square. If these all added up so that it is a magic square so far, then I check the diagonals. If it's not a magic square, then I don't bother checking the diagonals. And you could do the same type of thing here. That's what I was saying. So if it's magic, if it's still a magic square, go ahead and check the columns. Otherwise, if you know already from here that it's not a magic square, if I put those ifs in, it won't waste compiler time checking anything else, and it'll just print out that it's not a magic square. So hopefully that helps. I'm about out of time, and hopefully that will help you finish up Magic Square.